And point number 7 related with groups and electronic configuration is that as we go down in the group, number of orbits are increases, that we have seen. As we go down in particular group, for example in group number first, as we go down, the number of orbits are increases. Group number second also, from first element up to last element, as we go down, the number of orbits are increases. Okay, I will tell you how number of orbits are increases. Let us take one example. What is the point? Let me remind you. As we go down in the group, in particular group, take example of group number first. Group number first, it is called as alkali metal. Okay, group number first, alkali metal. Short form, that is okay. Hydrogen, lithium, sodium, potassium, rubidium, cesium and francium. Okay, these are the elements: hydrogen, lithium, sodium, potassium, rubidium, cesium, francium. These are the elements which are present in the group number first. We have seen, okay, you remember. So when we are going in the first group from hydrogen up to francium, hydrogen, then lithium, then sodium, then potassium, then rubidium, then cesium, then francium, what we have to observe? As we go down, hydrogen to lithium, lithium to sodium, sodium to potassium, potassium to rubidium, rubidium to cesium, cesium to francium. As we go down in the group number first, alkali metals, what we have to observe? Number of orbits or number of shells are increases. Let us see, start example. Group number first, I told you, okay, hydrogen, one electron is present, one shell is there. After hydrogen, lithium metal is there. In lithium metal, 2 orbits are present. After lithium, sodium metal is there. In sodium metal, 3 shells are there. After sodium, potassium metal is there. In potassium metal, 4 shells are present. What you are observing? You are observing group number first element, hydrogen, 1 shell, 1 orbit. After hydrogen, lithium, then 2 shells are present. After lithium, sodium, 3 shells are present. After sodium, potassium, 4 shells are present. Then it increases in rubidium, cesium and francium by 1. So this is important observation is that as we go down in the group, number of shells, that is orbit, number of shells or number of orbits are increases. So these 7 points are related with groups and electronic configuration. Hope student, you understood this point clearly. Okay. Then as we discuss in the beginning of this session, that in this session we are going to discuss only 2 points, that is groups and electronic configuration. Now second point of today's session, that is periods and electronic configuration. Okay, periods are there, periods and electronic configuration. That point we are going to see, periods and electronic configuration. So let me remind you what is mean by period. Okay, period, if you remember periods are, that is horizontal rows are present in modern periodic table. Okay, if you remember, these horizontal rows are present, that is called as period. Okay, you remember. Then second point, let me tell you, periods and electronic configuration, that is the point number 1. Okay, periods and electronic configuration, that is point number 1. Under the periods and electronic configuration, which point we are going to study? Listen carefully. Periods you understood? No. Once again, let me remind you that in modern periodic table, horizontal rows are there. If you remember, let me ask you one question. How many periods are there? Your answer will be 7. Total 7 periods are there. Okay. Now you understand. Okay. In the modern periodic table, total 7 periods are there. This concept you can keep in front of your mind. Let us start period. Now we have to find out what is the relation of period and electronic configuration. Let us start. Total 5 points are there. Point number 1. In the period, from left to right, left of the modern periodic table and right of the modern periodic table. In the period from left to right of the modern periodic table, first thing, atomic number increases by 1. If you go from in the period, now point is period and electronic configuration. Point number 1. In the period, if we travel from left to right, what you are observing? Atomic number increases by 1. What you are observing? What is your observation? In period from left to right, atomic number increases by 1. Okay? Let me tell you. First element in the period number second. First element, lithium, atomic number 3. Okay. Second, beryllium, atomic number 4. Atomic number increased by 1. Third element, boron, atomic number 5. Atomic number increased by 1. Fourth element, carbon, atomic number 6. Then nitrogen, atomic number 7. Then oxygen, atomic number 8. Then fluorine, atomic number 9. Then neon, atomic number 10. Lithium, atomic number 3. Beryllium, atomic number 4. Boron, atomic number 5. Carbon, atomic number 6. Nitrogen, atomic number 7. Oxygen, atomic number 8. Fluorine, atomic number 9. Neon, atomic number 10. These are the elements which are present in the period number second. You observe that as we go from lithium to neon, left hand side to right hand side, what you observe? Atomic number increases by 1. Hope you understand this point. Second point related with the periods and electronic configuration. What is that point? In the period from left to right, same. In the period from left to right of the modern periodic table, valence electron increases by 1. Okay. Valence electron, the electrons which are present in the outermost orbit, that is valence electron. You understand? You remember? In the period from left to right, valence electrons increases by 1. Valence electrons are increases by 1. Okay. Let me tell you. 3 example I will tell you. Now period number second. Once again we will take period number second. What we have to observe? In the period from left to right, valence electrons increases by 1. Okay, period number second. First example, lithium. Lithium atomic number 3. Electronic configuration 2, 1. So 1 electron is present in the outermost orbit of lithium. What we have to observe? Last electron increases by 1. So lithium 2, 1. In the last orbit, 1 electron is present. Second, after lithium, beryllium comes. Atomic number of beryllium, that is 4. Electronic configuration 2, 2. So in the last outermost orbit of beryllium, beryllium contains 2 electrons. Okay. So here lithium outermost orbit 1 electron, beryllium 2 electron, and one more example we will take, boron. Atomic number of boron is 5. Its electronic configuration. Electronic configuration of boron is a 2, 3. Now see, lithium electronic configuration 2, 1. After that beryllium electronic configuration 2, 2, and the boron 2, 3. What you observe? The number of electron in the last orbit, that is called as valence electron, increases by 1. Lithium 2, 1. Beryllium 2, 2. Boron 2, 3. Carbon 2, 4. Nitrogen 2, 5. So as we travel from left to right in the period, now here period we have taken period number second, we observe that the number of electron increases by 1. So this is the second important observation. I hope you understand this example, what we are explaining with the help of example also you understand, and point also you understood. Point number third, which is related with the periods and electronic configuration. What is point number third? In the period, as we go from left to right, as we go from left hand side to the right hand side, number of shells means orbit, as we go from, in the period, this is important, in the period, as we go from left hand side to the right hand side, number of shells or number of orbits remains the same. In the period from left to right, number of shells remains the same. Okay. Point number 4. Let us consider period number 3. Now, let us consider period number 3. Previously, now just what we have discussed. Remember, we have discussed point number 3. In the period, as we travel from left to right, number of shells, number of orbit remain the same. Let us check that. Let us take example of period number 3 and let us confirm that number of orbit does not changes. Let us confirm. Period number 3, first element sodium, electronic configuration 2,8,1. Okay, 2,8,1. 3 orbits are present in the sodium. 3 orbits, 3 shells are present. Magnesium, electronic configuration 2,8,2. Again 3 shells, 3 orbits are present in magnesium. Aluminium, electronic configuration 2,8,3 in aluminium. Again 3 shells are there, 3 orbits are there. Silicon, electronic configuration 2,8,4. Again, in case of silicon, 3 orbits are present, 3 shells are present. Phosphorus, in case of phosphorus, 3 shells are present. Electronic configuration 2,8,5. In phosphorus, 3 shells are present, 3 orbits are present. Then next, okay, with the help of this example, sodium, magnesium, aluminium, silicon, phosphorus, number of examples are there. With the help of this example, what we can observe, sodium 2,8,1, 3 orbits are there. Magnesium 2,8,2, again 3 orbits are there. Aluminium 2,8,3, again 3 orbitals are there. Silicon 2,8,4, again 3 orbitals are there. What we are observing in this period, important thing is that as we go from left to right in the period, number of shell remains the same. With the help of sodium, magnesium, aluminium, silicon, this we have seen, and that is the proved. Okay, this is the proved example that in case of sodium, magnesium, aluminium, silicon, the number of orbits, the number of shells remain the same. With the help of period number 3 example, I have given the explanation. Now last point, shells and electron capacity. How many shells are present? Total 4 shells are present. K shell, K shell, L shell, K shell, L shell, M shell, N shell. Okay, listen carefully. Let me remind if some mistakes will not be there. Total 4 orbits are there, 4 shells are there. First shell K shell, second shell L shell, third shell M shell, and fourth shell N shell. Now electronic accommodation capacity or electron accommodation capacity, that is called as simple word electron capacity. What is the electron capacity of K shell? The electron capacity of K shell is 2 electron. In K shell, maximum 2 electron can accommodate. Okay. Then what is the electron capacity of L shell? What is the electron capacity of L shell? Electron capacity of L shell is 8. Okay. Third one, electron capacity of M shell, M, capital M. Electron capacity of M shell is 18 electron. And last, electron capacity of N shell, capital N shell, is 32 electron. K shell 2 electron, L shell 8 electron, capacity of M shell 18 electron, and capacity of N shell 32 electrons. So here periods and electronic configuration, total 5 points we discuss. This point completes here. I hope in today's lecture we have completed groups and its electronic configuration, and second point, with the help of number of example periods and their electronic configuration we have completed. So it's a time to stop here. Again, in the new lecture, in the new video, we are going to meet. Please subscribe my channel Alchemy N. Keep watching Alchemy N. Thank you.